I would like to welcome you in this new chapter where we're going to be exploring the subject of building iterator support for our own containers. And when we talk about our own custom containers, please think of Box Container, a great container we've been building for a long time. Now, we have been talking about the STL for a long time, and it is made up of three parts. We have the containers, we have the iterators that navigate through these containers, and we have algorithms that do stuff on these containers through iterators. Now, from that, we know that iterators are really the glue that tie containers and algorithms together. Containers have to provide iterators, and algorithms are going to be looking for those iterators to work on those containers in a unified way. But what we have seen so far are things that are built into the C++ standard library. So what if we want our own containers to plug into the C++ standard library and use the already existing algorithms to manipulate our own data? That's what we want. So we want Box Container to be usable with the built-in algorithms like sort, find, fill, and all kinds of crazy things. And this is just to open a new world on what we can do with our own containers. It is even going to be usable with things we haven't thought about because they will be supporting iterators that are expected by the algorithms in the C++ standard library. So that's what we're going to be doing throughout this chapter. We're going to explore some of the algorithms and the iterators that these algorithms expect. Once we know that, we're going to head over in the meat of the chapter and build iterator support for our own Box Container class. And at the end, we want it to work this way. For example, we have a box container of int here, and we can use regular loops to loop through the data and do whatever it is we want. But we also want this, for example, to work with the range-based for loop. Now, some of you are going to think, isn't this going to work out of the box? Well, I hate to break it to you, that's not going to work because a range-based for loop is going to be using iterators behind the scenes. And if your container doesn't provide the needed iterators, range-based for loops are not going to work. Once we have the correct iterators, our container is going to work with some of the cool algorithms in the STL. Here you see an example of the fill algorithm. We can use the sort algorithm. We can use the find algorithm. We can really even use the range versions of these algorithms. This is what we want for our box container class. Now, we have seen a bunch of iterators. There is a hierarchy of them. We have input iterators, we have output iterators, we have forward iterators that provide the plus operator to be able to navigate forward in our container. We have bidirectional iterators that can go backwards. We have random access iterators that can jump around using pointer arithmetic-like operations. And we have contiguous iterators in C++20 that enforce the requirement for the data to be stored contiguously in memory. But we're not really going to be using contiguous iterators. We're going to stop at random access iterators. And you can explore these contiguous iterators yourself if you happen to need these in your C++ program. Okay, so the main goal of this chapter really is to be able to build iterator support for Box Container. And from what we know, iterator types are really a hierarchy. A forward iterator is also going to be an input iterator. A bidirectional iterator is also going to be a forward iterator. And a random access iterator is also going to be a bidirectional iterator. So if an algorithm needs a forward iterator, you can either pass in a forward iterator as is, but you can also pass in a bidirectional iterator or even a random access iterator. They are going to work, and they make a hierarchy that you can use to do these things. Okay, so some iterators are going to be needed for some algorithms. For example, the find algorithm need input iterators because it really needs to read things from the container. A fill algorithm is going to need a forward iterator because it's going to be looping around in the container to find the place where it's going to put the data. A reverse algorithm is probably going to need a bidirectional iterator. And the sort algorithm is going to need random access iterators to be able to do its job. So different algorithms are going to have different requirements in terms of the iterators that they need. That's the point I want to make here. Okay, now that you know this, we're going to head over in the next lecture and start really learning about the powers of iterators. And once we have that under our belt, we're going to embark on the journey to build iterator support for Box Container, our very own class that we built in this course here. So go ahead and finish up here and meet me in the next lecture.